This is SpaceTime, Series 23, Episode 103. Coming up on SpaceTime, the asteroid Bennu proving that life really is full of Vesta situations, NASA's science agreement with the US Space Force, and what was once thought to be the oldest piece of cosmology in existence, the Nebra Sky Disk, turns out to be Iron Age, not Bronze Age. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggests that material from the main belt asteroid Vesta has been discovered on the surface of the near-Earth asteroid Bennu. The new findings, reported in the journal Nature Astronomy, are based on observations by NASA's OSIRIS-REx spacecraft, which has been studying the 495-metre-wide Apollo group asteroid for the past 2 years. OSIRIS-REx was launched in 2016. The spacecraft is studying the evolution, composition and characteristics of this carbonaceous rubble pile asteroid. As they carried out their observations, astronomers noticed 6 boulders ranging in size from 2 to 5 metres scattered across Bennu's southern hemisphere near the equator, which appear to be some 10 times brighter than the rest of Bennu. And when they undertook more detailed spectroscopic measurements, they found the signatures, which included pyroxene, suggested that these particular boulders didn't come from Bennu, but from another asteroid, Vesta, located in the somewhat more distant main asteroid belt between Mars and Jupiter. A spectrometer separates light into its component colours, and since elements and compounds have distinct signature patterns in bright and dark across a range of colours, they can be identified using a spectrometer. And the signature from the Bennu boulders was characteristic of the mineral pyroxene, which is similar to what's seen on Vesta. Now, the leading hypothesis to try and explain the observations is that Bennu inherited the material from its parent asteroid body after a Vestoid, that's a fragment ejected by Vesta, collided with Bennu's parent body sometime in the distant past. Then, when Bennu's parent body asteroid was destroyed in another collision, a portion of its debris accumulated under its own gravity to form Bennu, including some of the pyroxene from Vesta. Astronomers don't think the boulders formed on Bennu's parent asteroid because pyroxene typically forms when rocky materials melted at high temperature, and Bennu's primarily composed of rocks containing water-bearing minerals, and so couldn't have experienced very high temperatures. Now, based on its orbit, several studies have indicated that it's possible that Bennu was delivered from the inner regions of the main asteroid belt into what is now its near-Earth orbit. And there are 2 inner main belt asteroid families, Polyna and Eulalia, that are both dark and rich in carbon, just like Bennu, making them likely candidates for Bennu's parent. OSIRIS-REx will make its first attempt to collect samples from the surface of Bennu in the next few weeks. The spacecraft will return to Earth in 2023, dropping off its samples into the Utah desert. This report from NASA TV.
It appears some pieces of asteroid Vesta ended up on asteroid Bennu, according to observations from NASA's OSIRIS-REx spacecraft. The new result sheds light on the intricate orbital dance of asteroids and on the violent origin of Bennu, which is a rubble pile asteroid that coalesced from the fragments of a massive collision. 6 boulders, ranging in size from 5 to 14 feet, were discovered scattered across Bennu's southern hemisphere near the equator. These boulders are much brighter than the rest of Bennu, with some appearing as much as 10 times brighter than their surroundings. The unusual boulders on Bennu first caught the team's eye in images from the OSIRIS-REx camera suite instrument. The signature from the boulders was characteristic of the mineral pyroxene from Vesta and the Vestoids, smaller asteroids that are fragments blasted from Vesta when it sustained significant asteroid impacts. The team tested a few different theories to determine the origin of these boulders. First, it's possible that the boulders were originally part of Bennu, or its parent body. However, this is unlikely based on how pyroxene is created. This mineral typically forms when rocky material melts at high temperature. Bennu is composed of water-bearing minerals, so it wouldn't have experienced very high temperatures in its history. Next, the team considered localized heating, perhaps from an impact. The scale of an impact needed to create large pyroxene boulders is much more significant than what is expected to take place in the main asteroid belt. So the team ruled out these scenarios, and instead considered other pyroxene-rich asteroids that might have implanted this material to Bennu or its parent. This is possible because as asteroids move through the solar system, their orbits can be altered in many ways, including by the pull of gravity from planets and other objects, meteoroid impacts, and even the slight pressure from sunlight. The new result helps pin down the complex journey Bennu and other asteroids have traced through the solar system.
Okay, let's take a break from our show for a word from our sponsor, ExpressVPN, rated #1 by TechRadar. You may be wondering why you need a virtual private network. Well, it's in the name. It's all about privacy. Do you really want big brother tech companies, hackers, governments, and who knows who else snooping in on your online activities? Now, you might not have anything to hide, but it's still really creepy, and it could be dangerous for you and those you care about. Also, how often do you run across a website and you want to get information from it, but you find out that they're geo-blocked? It's all very frustrating, and it's becoming an increasing problem. And that's where ExpressVPN can help you. ExpressVPN's a simple and efficient way to protect your online privacy. It's internet without borders from the world's leading VPN provider. So, protect your online privacy today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more. And of course, you'll find the link details in the show notes and on our website. That's tryexpressvpn.com/space. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
NASA has signed a memorandum of understanding with the new United States Space Force. Although NASA is meant to be a civilian operation, the ties linking NASA and the United States Defense Department are strong and deeply intertwined in terms of personnel, technology, equipment, goals, national security, scientific research, and support at all levels. The new agreement, announced by NASA Administrator Jim Bridenstine and U.S. Space Force Chief of Space Operations General John J. Raymond, commits both organizations to broad collaboration in areas including human spaceflight, American space policy, space transportation, standards and best practices for safe operations in space, scientific research, and planetary defense. The new memorandum replaces the old agreement signed between NASA and the U.S. Air Force Space Command, under which the two organizations engaged in research and development information, sought to reduce the duplication of system development, and collaborated in the long-term planning of each organization's space roadmaps. This is SpaceTime. Still to come, a new study claims the Nebra Sky Disk, what was thought to be the world's oldest depiction of the cosmos, is actually 1,000 years younger than previously thought. And later on Skywatch, the spectacular Southern Cross and the stars of our nearest neighbouring star system Alpha Centauri are the highlights of the October night skies. All that and more still to come on SpaceTime. A new study claims the Nebra Sky Disk, an ancient cosmological sky map thought to be the world's oldest depiction of the cosmos, is actually around 1,000 years younger than previously thought. Archaeologists from Goethe University in Frankfurt and the Ludwig Maximilian University in Munich say the 30-centimetre wide disk, which was originally thought to date back to around 1600 BCE in the Bronze Age, is now believed to be Iron Age, based on a new study of the Saxony-Anhalt site where it was discovered. The 2.2 kilogram blue-green gold disk is inlaid with gold symbols, including an orb interpreted as being either the sun or the full moon. There's also a lunar crescent and multiple stars, including a cluster of 7 which are thought to represent the Pleiades or 7 sisters. 2 golden arcs along the side, which were added later, are thought to mark the angle between the solstices. A final addition was another arc at the bottom of the disk, surrounded with multiple strokes, variously interpreted as either some sort of solar barge with oars, the Milky Way galaxy, or a rainbow. This is SpaceTime. And time now once again to turn our eyes to the skies and check out the celestial sphere for October on Skywatch. October is the 10th month of the year. That may seem somewhat confusing as octo means 8 rather than 10. The answer lies in the old Roman calendar, which had just 10 months before the addition of January and February. And that 10-month year is still reflected today, with the name September or Septem being Latin for 7, October or octo meaning 8, November or novem 9, and December or deci meaning 10. The 31st or last day of October is of course celebrated as Halloween or All Hallows Evening. Halloween's based on ancient Celtic pagan festivals such as Samhain, the Gaelic festival of the dead. It's a time when darkness overtakes the light of day, a reference to the increasing hours of darkness as the Northern Hemisphere moves towards its long winter nights. It's meant to signal the end of the harvest. Samhain was eventually Christianized by the early church to become All Saints, All Hallows Eve, in other words Halloween. It's a time when the increased hours of darkness, meaning the boundary between the world of the living and that of the dead, was especially thin, thereby allowing the dead and the supernatural to rise in search of the living. And so the living are meant to wear disguises, so as not to be recognized by the dead, and it's this which has led to today's tradition of the Halloween fancy dress party. In some parts of the world, cross-dressing was popular on Halloween, a reflection of the secret desires and fantasies of their pagan ancestors. To ensure that crops and livestock survived the cold winter months ahead, offerings of food and drink would be left outside for the spirits or fairies from the other side. And that's ultimately led to today's practice of trick-or-treat. Candles would be lit and prayers formally offered to the souls of the dead, as Halloween was a time when the spirits of the dead would return to their former homes. Special bonfires would be lit on Halloween in order to light up the darkness, thereby preventing the souls of the dead from returning and for keeping the devil away. The flames, smoke and ashes were deemed to have protective and cleansing powers and were used for divination. Apple bobbing originated because the apple was a Celtic symbol of love, and so grappling the apple in your teeth had certain erotic overtones. Now, as for carving pumpkins into jack-o'-lanterns, that was originally meant to either represent spirits or supernatural beings, or alternatively to ward off evil spirits. In many parts of the world, Christian religious observances for All Hallows Eve include attending church services and lighting candles on the graves of the dead. Christians historically abstained from eating meat on All Hallows Eve, a tradition reflected in the eating of certain vegetarian foods on the day, including apples, potato pancakes, and soul cakes. And of course, Halloween's also a time for fortune-telling and divination games, playing pranks to scare people, visiting haunted attractions, telling scary stories, and watching horror movies. Okay, turning to the night skies now. And looking to the southwest, you'll see the two bright pointer stars of the Southern Cross. These two bright stars, one above the other, are known as the pointers. The two pointer stars that help us find the Southern Cross. The Southern Cross, of course, is the best-known constellation in the southern skies. The brightest, and also what looks like the furthest away from the cross, is Alpha Centauri, the nearest star system to our own solar system. Alpha Centauri is a triple star system comprising two stars, Alpha Centauri A and B, a binary system which orbit each other, and a third star, Proxima Centauri, which orbits the pair. Like the Sun, Alpha Centauri A is a spectral type G yellow dwarf star. It's about 10% more massive than the Sun and about 1.5 times as luminous. Astronomers describe stars in terms of spectral types, a classification system based on temperature and other characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars, followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish yellow stars, spectral type G yellow stars, that's where our Sun is, spectral type K orange stars, and the coolest and least massive stars known are spectral type M red stars. Each of these spectral classifications can also be subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and then a Roman numeral can be added to represent luminosity. Putting all this together, our Sun is officially classified as a G2V yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were born as spectral type M red dwarf stars, but became brown dwarfs after losing some of their mass. brown dwarfs fill a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are somewhere between 75 and 80 times the mass of Jupiter, or about 0.08 solar masses. Alpha Centauri A's binary partner, Alpha Centauri B, is a spectral type K orange dwarf star, a little smaller and cooler than its companion, with about 90% the Sun's mass and about half of its luminosity. Now, this pair orbits each other at between 11.2 and 35.6 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, which equates to about 150 million kilometres or 8.3 light minutes. So, the pair's orbit around each other varies between the average distance between Saturn and the Sun and Pluto and the Sun, two stars orbiting each other every 79.91 Earth years. Alpha Centauri A and B are located at an average of 4.37 light-years from the Sun. Now, it sounds like a measure of time, but a light-year is actually a measure of distance. It's a distance of about 10 trillion kilometres, the distance a photon can travel in a year at the speed of light, which is about 300,000 kilometres per second in a vacuum, the ultimate speed limit of the universe. The third star in the Alpha Centauri triple star system is a spectral type M red dwarf star known as Proxima Centauri. It's called Proxima Centauri because it's only 4.25 light-years away, making it the nearest star to the Earth other than the Sun. It's loosely gravitationally bound to Alpha Centauri A and B, orbiting the pair at an average distance of about 13,000 astronomical units, or about 0.21 light-years. That's about 430 times the size of Neptune's orbit around our Sun. In 2016, astronomers confirmed the existence of an Earth-sized terrestrial planet orbiting in the habitable zone around Proxima Centauri, making it the nearest extrasolar planet or exoplanet to the Earth. The planet, known as Proxima B, takes just 11 Earth days to complete one orbit around its host star. Now that's far closer than Mercury's 88 Earth day orbit around the Sun. Earlier this year, there were signs of a possible second planet orbiting Proxima Centauri, although the exact details of Proxima C are still being finalised. The second or slightly fainter of the two pointer stars is called Beta Centauri, and while Alpha Centauri is the third brightest star in the night sky, outshone only by Sirius and Canopus, Beta Centauri is only about the 10th brightest star. Looking towards the southeast, you will see the bright blue-white star Alpha Eridani, or Akana, which represents the southern tip of Eridanus, one of the largest and longest constellations in the sky. Akana is located 139 light-years away. It's actually a binary star system comprising two stars, Alpha Eridani A and Alpha Eridani B. Alpha Eridani A is a young, hot spectral type B blue-white star, about 6.7 times the mass of the Sun, with a stunning 3,150 times the Sun's luminosity. The companion star, Alpha Eridani B, appears to be a spectral type A white star, with about twice the mass of our Sun. The two stars orbit each other every 14 to 15 Earth years at an average distance of about 12.3 astronomical units. Because of its high rotation rate at over 16 kilometres per second, Alpha Eridani A is one of the least spherical stars in the Milky Way, spinning so rapidly it's assumed the shape of an oblique spheroid, with an equatorial diameter some 56% greater than its polar diameter. This distorted shape means the star displays significant latitudinal temperature differences, with its polar temperature being above 20,000 Kelvin, while its equatorial temperature is around 10,000 Kelvin, because it's much further away from the stellar core. The high polar temperatures generate a powerful polar wind, ejecting material from the star and creating a polar envelope of hot gas and plasma. Located between the south celestial pole and Akana are two faint fuzzy-looking clouds. Now, these are actually two satellite dwarf galaxies which orbit the Milky Way, known as the Large and Small Magellanic Clouds. They're named after Ferdinand Magellan, who became the first European to officially record them during his expedition to circumnavigate the Earth between 1519 and 1522. The bigger and nearer of the pair is the Large Magellanic Cloud. It's about 14,000 light-years across, roughly twice the size of the Small Magellanic Cloud, which is located about 200,000 light-years away. Now, by comparison, our own galaxy, the Milky Way, is some 100,000 light-years across. The two dwarf galaxies are separated by approximately 75,000 light-years. They were considered the closest galaxies to the Milky Way. That was at least until the 1994 discovery of the Sagittarius dwarf elliptical galaxy, and then the 2003 confirmation that the Canis Major Dwarf Galaxy is actually our nearest galactic neighbour. The total mass of the Magellanic Clouds remains uncertain. Only a fraction of their gas seems to have coalesced into stars, and they probably both have really large dark matter halos. Although one recent estimates placed the total mass of the Large Magellanic Cloud at around 1/10 the mass of the Milky Way. The Magellanic Clouds have both been greatly distorted by gravitational tidal interactions as they're gradually torn apart and absorbed into the Milky Way. These huge tidal forces have turned both clouds into irregular disrupted barred spiral galaxies. The Large Magellanic Cloud retains a very clear spiral structure in radiotelescope images of neutral hydrogen. And there are streams and bridges of neutral hydrogen gas clouds and isolated stars, connecting both dwarf galaxies to each other and the Milky Way. It's all a clear example of galactic cannibalism at work. Now, if you have a backyard telescope or a good pair of binoculars, take a look just above the small Magellanic Cloud and you'll see a small blurry dot. That, my friends, is the 47 Tucani globular cluster, a tightly packed ball of stars some 16,000 light-years away. They were all originally formed at the same time through the gravitational collapse of the same molecular gas and dust cloud. Looking to the west and you'll see a bright reddish-orange supergiant star. That's Antares, the heart of the constellation Scorpius the Scorpion. Above it you'll see a bunch of stars stretched out like a reverse question mark, and that's the tail of the Scorpion. And just above that and to the north is the constellation Sagittarius the Archer. Sagittarius shows the way to the supermassive black hole, Sagittarius A star, located at the centre of our galaxy some 27,000 light-years away. Sagittarius A star has about 4.3 million times the mass of our Sun, and it's the point around which our entire galaxy rotates. If you look towards the north-northwest in the constellation Lyra the Harp, you'll see its brightest star Vega, the fifth brightest star in the night sky, and one of the closest, just 25 light-years away. Vega is a spectrotype A white star, more than twice the size and some 40 times the mass of our Sun. And just to the right of Lyra and almost directly north just above the horizon is the constellation Cygnus the Swan and its brightest star Deneb, one of the most luminous stars in the sky. Deneb is a massive spectrotype A white supergiant, some 19 times the mass and more than 100 times the diameter of the Sun. The star is somewhere between 55,000 and 196,000 times as luminous as the Sun. The huge range in luminosity estimate comes about because it's difficult to determine Deneb's exact distance from us. Science's best estimates place it at somewhere around 2,600 light-years away, give or take 112 light-years. Also high in the northern sky is the constellation Aquila the Eagle, and its brightest star Altair. Altair is a spectrotype A white star, located just 17 light-years away. It's about 10 times brighter and 1.89 times the mass of our Sun. Despite its size, Altair spins on its axis in just 10 hours. That compares to our Sun's rotational period of around 28 Earth days. Now, the three stars Altair, Deneb and Vega form what's known as the Summer Triangle, a stellar grouping. Now, there are also three meteor showers in October: the Draconids, the Taurids and the Orionids. The Draconids take place on October the 8th. They're so named because their meteors appear to radiate out from the constellation of Draco the Dragon and so are best viewed from the northern hemisphere. They're generated as the Earth's orbit takes our planet through the debris trail left behind by the comet 21P Gaiakabani-Zinner, which takes about 6.6 Earth years to make a revolution round the Sun. The Taurids meteor shower takes place on October the 10th, and as their name suggests, they appear to radiate out from the constellation Taurus the Bull. The meteors are composed of larger-than-average pebbles and dust grains, and are thought to be generated by debris from the comet 2P Encke, although it's thought both the Taurids and Encke could be the remains of a much earlier comet which disintegrated over 20 to 30,000 years ago, breaking into several pieces and releasing material both by normal cometary activity and also possibly by gravitational tidal interactions with the Earth and other planets. The Taurids debris stream is the largest in the inner solar system, and it'll take the Earth several weeks to pass through it, resulting in an extended period of meteor activity compared to other meteor showers which are usually over in a couple of days. Due to the gravitational perturbations of the planets, especially Jupiter, the Taurids have been spread out over time, allowing separate segments, labelled the northern and southern Taurids, to be observable at different times in different hemispheres. The southern Taurids are active from about September the 10th right through to November the 20th, while the northern Taurids are active from about October the 20th through to December the 10th. The Orionids meteor shower will peak on October the 20th and are caused by debris from the comet Halley, which also causes the annual Eta Aquarids meteor shower in May. Comet Halley takes 76 years to complete each orbit around the Sun and will next be visible from Earth in 2061. The Orionids are equally spectacular in both the northern and southern hemisphere skies, with up to 20 meteors an hour radiating out from the constellation Orion. The best time to see the Orionids is just after midnight and right before dusk. And joining us now to take us through the rest of the October night skies is Jonathan Alley, editor of Australian Sky and Telescope magazine.
G'day, Stuart. Well, for October here in the Southern Hemisphere, it means we're in spring, heading towards summer. Our friends in the northern half of the planet, of course, are autumn heading towards winter. So their hours of darkness are increasing. Our hours of darkness are slowly decreasing. We're going to get to summer, and of course, then daylight saving comes in. So spring's actually a really good time, good middle ground, because you've got nice long nights still. The weather's warmed up a little bit, so it's quite pleasant, and it's not pelting with rain in most places. The stormy season hasn't hit yet. That comes a little bit later on. So it's a really good time of the year to get out and do some stargazing. So from where I am, evenings are really good. It's nice, and the nights are good. I've just been outside having a look, actually. And up high, you've got the Milky Way.
Checking the seeing.
Checking the seeing, yeah, exactly. The seeing is the sort of quality of the night, of the air and the visibility. So when stars are twinkling, that means that there's lots of air currents up there that are disturbing the light coming in from the stars. And astronomers don't like twinkling stars. They look pretty to the naked eye, but they're just sort of, when you look through a telescope, for instance, you really see that it's unsteady, unsettled seeing. What you really want is a crisp, cool, still night where the stars are really sharp and pinprick points, and you don't see them twinkling at all. So they're the best.
And I guess we should spare a thought for our North American listeners right now, because they wouldn't be seeing much of all that smoke coming from the West Coast fires.
That's correct, the smoke. Yeah, well, we know exactly what that's like. The ones we had at the beginning of the year.
At the beginning of the year, yeah.
Yeah. And look, other places around the world as well, I'm sure. And not only us, the smoke on that side of the country, but of course they've had hurricanes on the other side of the country. So
yeah, they're really copying it, aren't they?
Yeah. Well, we feel for all those people, which is another good reason why, when things are good, get out there and enjoy nature, right? I've had this conversation recently with someone else. Why do you look at the stars? Well, I say, why do people go on a bushwalk or go to the beach or go diving on the Great Barrier Reef or something? Because they're enjoying nature. It's the same thing with stargazing. You're just enjoying nature. It's a marvellous part of nature, and it's really incredible. It's something beyond our planet, and it's mind-expanding and imaginative, and it was something, away from the humdrum of the daily rat race. So it's just good to get out there and look at the beautiful stars. I mean, they're just really wonderful.
And looking at the stars is something you can do on your own while wearing a mask, so you don't have to worry about catching COVID-19.
I reckon there have been a lot of amateur astronomers out there doing much more observing than before. I've been getting flooded with photographs that people have been sending in, far more than usual. So people are taking this opportunity to indulge in their hobby. So I guess when you can, why not? And look, you don't have to have super expensive equipment and things. You can just get a pair of binoculars and go out and enjoy the night sky, or just your own eye with a little star chart or something. It doesn't have to be really expensive. So you can buy a $25,000 telescope too. You can buy telescopes that cost a lot more than that, but you don't need to. You can just enjoy the night sky with the naked eye and a little star chart and learn your way around the sky. So if you're out there tonight and you look up, you'll see the Milky Way, which is the band of stars that is our galaxy seen from the inside, and it's stretching from north to south. It's sort of in the western half of the sky after it gets dark. The constellations Sagittarius and Scorpius are there. Scorpius really does look like a scorpion, and they're very easy to see. But as the night goes on, you get to about midnight, and the Milky Way has disappeared because it's set below the western horizon as the Earth has turned. What that means then is what's left in the sky this time of year, it looks a bit bare because we're looking out of the plane of our galaxy. Our galaxy is like a discus shape, and instead of looking through the thickness of the discus, we're looking out of the discus, sort of up or down through the thin part. So we don't see quite as many stars. But there are quite a lot of good things still to see. So for us in the Southern Hemisphere, of course, things we always love to see, particularly in summertime, is the Magellanic Cloud galaxies. These are two nearby galaxies to our Milky Way. They just look like fuzzy clouds. Yeah, you can't make out any detail in them with the naked eye, but if you've got a dark spot and your eyes are dark adapted, so you haven't been staring into a computer screen or something, so your eyes are adjusted to the darkness. You can see them, they just look like clouds, and they are actually huge galaxies quite nearby, and they're named after the explorer Magellan. And they're down there, down south, about halfway up from the horizon this time of the year. There are two of them, the small and the large. So get out and see if you can spot them. If you're looking for the Southern Cross and you can't find it, that's okay. Don't think you're going mad. Don't panic, because at the moment it's upside down and very, very low on the horizon. And for some people, in fact, around Australia or New Zealand or in the African countries or South America, depending on your latitude, it actually might be below the horizon this time of year, so you can't see it at all, certainly in the evening time at least. So it's not a good time to see the Southern Cross at the moment, but it is a good time to see the Magellanic Cloud. And if you like staying up late or getting up early, the post-midnight skies in October are great, because I said that the Milky Way is setting in the west in the evening, and it goes down there and it's disappeared. Well, come the morning time, it comes up again in the east, and we see the other part of the Milky Way. So you've got the constellations Orion and Tauris and Gemini and Puppis and Canis Major and all these wonderful things. Some of them might not sound familiar to a lot of people, but they're really great constellations to see in the Milky Way. Lots of bright stars. Get a pair of binoculars and things onto them, and you can see lots of nebulae and star clusters and things. So, for instance, Canis Major, I mentioned, that's got the brightest star in the night sky, Sirius. Very easy to see, of course, because it's the brightest thing you can see up there. Orion, we've spoken about plenty of times, with two bright stars, Rigel and Betelgeuse.
And Betelgeuse is visible again now. It sort of almost disappeared completely for a while there. People thought it might have been about to go supernova, but we now know it wasn't. It was just covered by a lot of dust that it had made.
Yeah, it's just sort of a dusty atmosphere, and it just sort of blocked a lot of the light. So it's good.
It had a big burp of plasma, and as the plasma moved away from the star itself, it condensed into dust and blocked out most of the southern hemisphere light coming from Betelgeuse.
Happens to me sometimes too. Now let's have a look at the planets. So in the evening, high overhead in the early evening, for us here in the south at least, we've got Jupiter and Saturn. They're quite close together. Jupiter's the brighter one. You cannot miss them. They're brighter than any of the stars surrounding them. So if you look up and you see two bright star-looking things, that's Jupiter and Saturn, and Jupiter is the brighter one. Mercury you can find fairly low on the western horizon after sunset. It doesn't look that spectacular. It's just like a bright pinpoint star, but it is a planet, not a star, and it's the innermost planet, the one that's closest to the sun. If you're a morning person at the moment and you're up early, you'll see Venus in the eastern sky. Big, bright, unmistakable. Again, brighter than anything that's surrounding it in the sky, except the moon, which sometimes sort of is nearby as it does its orbit around the planet. So Venus always looks amazing. And Venus is that planet where someone will suddenly look up and think, what's that bright star? I've never seen that before. That wasn't there yesterday. And they ring you up and they say, what's that bright star? And I say, it's Venus. Oh, it wasn't there yesterday. So I'm telling you it was. It's been there all week. It's been there for weeks. I never noticed it. Just one of those things where you look up and you think, what on earth is that? It's so big and bright and bold and stunning. You think, how didn't I see that before? So you've got to look up. But the star of the show this month, I've left it till the last, is the planet Mars. All right. So planet watchers have been waiting for a couple of years for this month to arrive since the last time that Mars was closest to the Earth, because now, this month, is when Mars will be closest to us in its orbit. The day of closest approach is October the 6th, and it'll be just over 62 million kilometres away, which is just under 39 million miles, which is fairly close as these things go.
How does that compare with other Mars close encounters with the Earth over the years? Is it about average, or is it closer than normal? Or? It's
an average sort of one. It's certainly been closer and better in the past, and I think this is the last reasonable one. I think now until about 2030 or something. So that's why that people have been waiting for this one, because after this, the next closest approach, which come around roughly every 2 years, the next ones won't be that great. And that brings me on to the next point. Why isn't it great? And that's because Mars is a small planet, much smaller than the Earth, and it's 62 million kilometres away. So you look through a telescope and it still looks small, even looking through a telescope, even a big telescope with high magnification. So when something's small, you get better viewing of it when it's closest to you. That's why astronomers really like this period when a planet is making its closest approach. Venus actually comes closer to the Earth than Mars does, but Venus, you can't see anything on Venus. It's just covered in clouds. There's not a lot to see. But Mars, you can see stuff on the surface in broad scale, depending on the size and power of your telescope. So planetary observers will be keeping an eye on the shrinking southern polar ice cap, and they'll be looking to see if any dust storms blow up. Sometimes you can get a dust storm on Mars that just covers the entire planet. It starts off in one region and it just gets going and it snowballs, and they can cover the entire planet with dust and just completely ruin the view. I don't remember which spacecraft it was. It was one of the very early spacecraft that I think NASA sent to Mars back in the 60s, or was it one of the Vikings in the 70s? Got all the way there, and just as I arrived, a huge planet-wide dust storm kicked off.
Was that one of the Mariner ones?
It could have been one of the early Mariner ones, yeah, and it lasted for weeks. So they just had to wait in orbit and wait until this dust storm settled down till they could get a bit of a view of the planet below. So, as I say, let's hope that doesn't happen this time and people do get a good view, because this will be the last fairly good close approach of Mars for another 10 or 12 years or so. And with October being close approach month, even about a month or so later, when we get into November, Mars will be receding in distance from us because the Earth is on the inside orbit and we're going faster, so we're sort of pulling away from Mars, and Mars will therefore be getting further away from us.
So from our point of view, Mars looks like it's now going backwards.
Correct, yeah. So Mars we're sort of leaving it in its dust. It's like track and field runners. Someone's on the inside track and someone's on the outside track. And if the runner on the inside track is going faster, well, the one on the outside track is just going to be left behind. That's the way it happens.
They call that in retrograde. Mars is in retrograde. Is that what they say?
When it appears to go backwards in the sky, that's what you call retrograde, yeah. So the distance will be opening up between the two of us, and therefore Mars will appear to be smaller and smaller and smaller as the distance opens up, and it does get quite small. And so even through very large backyard amateur telescopes, you don't get to see a lot. So that's, as I say, that's why this time of the year, this year at least, is when everyone's going to be looking at Mars.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.